In the last few sessions, we've introduced the idea of multiple regressions, where we've got more than one explanatory variable. And in the last session, we started talking about the California data that we've been looking at, where we have a non-linear relationship in terms of the average income. So we included both the average income and the average income squared term. Now, a question that this might raise with you is, given that we've got this non-linear specification in terms of average income, could we test, using both average income and average income squared, whether average income as a whole has an impact on test scores? So in other words, we've got these multiple explanatory variables linked with average income. Could we use something to do with the average income and average income squared terms to test the null hypothesis that average income as a whole has no impact on test scores? So one possible strategy that we might use is we might say, well, if we wanted to test the hypothesis that average income has no impact on test scores, this would be equivalent to beta 2 and beta 3 both being equal to 0. So in other words, we're going to set a null hypothesis that beta 2 is equal to beta 3 is equal to 0 against an alternative that either beta 2 is non-zero, or beta 3 is non-zero, or both of them are non-zero. Now, what strategies could we use to try and test this hypothesis? Well, one strategy probably jumps out to you straight away, because you're thinking, well, if beta 2 is non-zero or beta 3 is non-zero, then we're going to reject this null hypothesis. And we've tested null hypotheses before that for beta 2 being equal to 0, or we've tested a null hypothesis that beta 3 is equal to 0. We've simply used t-tests in the past. Now, one possible strategy that we might have to try and test this joint hypothesis here that beta 2 and beta 3 are both equal to 0 might be simply to look at the null hypothesis that beta 2 is equal to 0 against the alternative that it's non-zero, the null hypothesis that beta 3 is equal to 0 against the alternative that it's non-zero, and then if we reject the null in either, maybe that's sufficient in order to reject our hypothesis that beta 2 is equal to beta 3 is equal to 0. So a question that we're going to ask ourselves, and we're going to ask ourselves later in the session, if we reject the null hypothesis for either of these t-tests, would we also automatically reject the null hypothesis that beta 2 is equal to beta 3 is equal to 0? So before we go ahead and find out whether or not this is a valid strategy, let's just construct our t-stats for the individual hypotheses and see whether or not we reject these two individual null hypotheses. So we'd construct t-statistics in the normal way if we're testing an individual hypothesis. So if we want to test that beta 2 is equal to 0 against the alternative that beta 2 is non-zero, we take the estimated beta 2 hat, subtract the expected value of beta 2 hat, conditional on the null being true, divided through by the estimated standard error, and that gives us an estimated t-stat of 12.85. We've got 420 observations. We're estimating 4 coefficients of beta 0, beta 1, beta 2 and beta 3, so we've got 416 degrees of freedom. The critical value is 1.96. Because our t-statistic is larger than the critical value, we reject the null. Similarly, we can do the same with beta 3. We construct the null hypothesis that beta 3 is equal to 0, the alternative that beta 3 is non-zero. We construct a t-statistic in the normal way, and our t-statistic is minus 7.33. Again, it's larger than the critical value in terms of magnitude, so we reject our null hypothesis. Now, we've rejected the null in both of these individual tests. We've rejected the null that beta 2 is equal to 0. We've rejected the null that beta 3 is equal to 0. But we haven't answered the question yet, is this enough to also reject the joint hypothesis that beta 2 is equal to beta 3 is equal to 0? So we've not yet answered the question about whether we've been able to jointly reject the null hypothesis that beta 2 is equal to beta 3 is equal to 0. Now, as a spoiler, it turns out that just because you reject the null in one of the individual tests, that's not sufficient to reject the null in the joint test. Now, in order to begin to motivate this, there is a problem for you to attempt below this video, and when you've had a go at that problem, there's a video to follow up going through the solution, and then we're going to build on that to analyse this joint hypothesis test.